keynote speaker will actually tell you that developers at any stage can learn from operations mentalities and practices. She speaks from 20 years of battle-tested experience participating in incident response at every level in organizations of every size. She is now a senior software engineer in site reliability at GitHub, and her talk is titled, Putting the Ops in Dev, How to Bring Operational Experience to Your Development. Please help me welcome Lauren Rubin.
I was going to ask for a show of hands of how many people here who are on call right this minute, right now. Okay, I am actually on call right this minute. I like to live dangerously. If my phone beeps with the specific noise that means I have been paged, I'm sorry, I am going to look at it. My other coworkers can take up the slack for me, and it would be simple, so no problem. Don't worry about that. So I titled this Putting the Ops in Dev, or How to Stop Worrying and Love the Pager. And a lot of what I was thinking about when I wrote this talk was things that are top of mind for me at the moment in trying to start a grassroots effort, really, to have developers want to learn these operational things. Because, you know, in my career, I've been doing this for 20 years. I've worked at that tiny, scrappy startup that there are 10 people, and you're that one ops person, and they're just constantly like, hey, we're having a problem with something that has an LED in it. Can you come help, please? All the way up to super huge, what we call now like global scale or planet scale type of companies that are worth lots of money and have huge, huge moving systems with, and regardless of this 20 years ago or today, thousands and thousands of employees touching thousands and thousands of moving parts, right? And I'm going to make this deck available. It contains links in it. I'm trying to come up with something where I'm going to post this, and then the rest of us who are more operations focused can take this back to our own organizations and to our own like open source projects that we might be working on, and we can evangelize why it actually is helpful for the developers to learn operational concepts, and that in fact, it's going to reduce the overall amount of pain for all of the human beings at your company if developers understand and think about certain operational practices. Another interesting thing now that I look at this, two things really quick. I spent 3 years at a very large company doing basically just postmortem meetings. I don't care for that term, but I will continue to use it because everybody knows what I mean when I say it. But let's just say that this company graciously afforded me an attitude to, for 3 years straight, lead a very high-stakes incident review a couple times a month. So I'm not going to name the name of who that is, but the amount of like skill and craft that I developed from that, I think, is very interesting. And it's very interesting to know that actually one person in your postmortem meeting can start making a difference. So what I learned collectively is something that I actually noticed I couldn't find when I started to take computer science classes. So I actually have a non-traditional career path. I decided in high school that I could be making a lot of money in the first .com boom. I'm dating myself, but you already know how long I've been doing this. And 2 weeks out of high school, I left and I had a sysadmin job, right? So what I learned from that was like, I started taking college classes on the side. That's what your parents tell you to do, or you're going to end up living in a box. So I went to the local community college, which actually has quite an interesting computer science staff because of their geographic location. A lot of their teachers are the person who wrote the programming language, or somebody who worked for HP who designed these really low-level, really interesting things that we all depend on. And it was really good curriculum. What I noticed is that when I would go to classes, none of what they talked about was particularly like relevant to what I was doing every day, right? Because they were teaching me, okay, this is assembly, these are the registers in your CPU, this is how you move data in and out of them, this is how it works at a higher level language, and so on. And I would sit there and I would think, oh, okay, maybe this Unix class is going to be the one that like teaches me more about being a Unix sysadmin in the business world. No. And I sat there and I thought, why doesn't it apply to my job? Because my job, my real actual job in operations at a company is basically to sit around going, what the heck is going on and what do we do about it? And they don't teach that in college. And so the way that I have learned this is the hard way over and over again, being the people in the basement, right, as we say. So, and I also learned that this is an underappreciated skill, and I think that's part of why it's not currently taught academically. More on this later, but there are starting to be sort of academic inroads, and I'm very pleased to see that, and I have links for it. But accidents, events, incidents, whatever you want to call them, 100% probability that they are going to happen. I will bet money on that. I will bet my entire year's salary that there is a 100% probability of an incident in your environment. We can get into some shades of gray of what's an incident. That's a whole rabbit hole of academic study, right? But I'm going to tell you, things are going to go wrong, guaranteed, varying levels of wrong, all the time. When you respond to that thing that is wrong, it's probably not going to be like, you're never going to sit back and go, you know what? Everything that we did in response to that unexpected situation, it was all awesome. Nobody made any mistakes. All of the tools worked. The power didn't go out. Nobody was sick. Everything was just magic. Like that cannot happen. And I think that operations stuff in general and incident response is significantly different from other areas of business because you can and should and will do planning about what to do when you have an incident or an adverse event. But unlike many other things, there's absolutely no way to actually know what you are planning for. You will never know what you're planning for. You will never, ever, ever prevent incidents by sitting down and writing every single thing that went wrong in the last one, taking note of that, making sure that thing can never go wrong again. Guess what? You're still going to have incidents. And that's actually a really tough human concept that no matter how hard I try and no matter how much I plan, they're still coming, right? And they're not going to run smoothly. But what you can do is to understand that and to say, okay, if I know for sure that someday, probably soon, and then again, something's going to be really not good, right? Things are not going to be fun. And I know that I'm going to need some number, probably multiple human beings to notice this, decide they need to do something, then they need to do things. And just being able to plan for the human parts of this to say, hey, people involved in this, we support you. We have spent time not thinking of rules to prevent humans from making mistakes. We have spent time understanding where the people have struggled during the incidents. Another thing I think we've heard a little bit about here, and because this is a non-dev and all ops kind of a crowd, let's be real here. We all have probably even within the last week had some conversations with our leadership at the company, maybe even somebody with a C in front of their title, and we say, hey, we need this thing, whatever this is, requires resources, does something, right? The executives are like, no, that doesn't sound exciting, right? It's the people in the basement who are watching something be on fire saying, hey, it's on fire. But while we're doing that, you would think, if you're like, hey, it's on fire, look. You would think most rational leadership would look and say, well, that's bad. We don't want it to been on fire 10 times this week. We don't like that. We don't want it to be on fire. The problem is that while you're jumping up and down, it's on fire. Look, there's smoke, the whole room. What's going on? The marketing department has a stage with a band and a crowd that they've paid to show up. And this marketing organization walks out on the stage looking great. I mean, the production value of this is so good. And they say, we have a life-changing thing that if you give us all of the money from next year's budget, like there will be 2 worlds. It will be amazing. It's unbelievable. And obviously, like marketing is going to win that discussion, right? But hope is not lost because we can change the attitudes of the people at the company and we can make everything better for the people at the company. And once enough of the straight developer people actually have lived through doing the operations and they haven't been lucky enough to be able to avoid it through systems that let them avoid the pager rotation and the responsibility, those people eventually make it up into management. And then those people who have lived in those operational circles will be like, oh, you're telling me that operationally this is not tenable. Now I'm listening, right? And one thing that I'll say I've learned very recently, which has completely blown my mind and shifted my perspective quite a bit, I spent most of those 20 years as the very traditional ops gating role. Oh, these developers, they keep throwing this code over the wall. The only thing that we can do to get our bonus and keep the site up is to stop them from doing it because every time they do it, it's going to break, right? The rules don't help that. And in fact, they make it worse, because your idea for a grand process and tooling system that like prevents people from making mistakes, it's not going to prevent them from making mistakes, but it's going to prevent them from being flexible and creative. And they're not going to like it. And so it becomes this adversarial thing where people want more rules to make operations better, but you're not actually changing anything. You're not changing the dynamic between the teams. You're not changing who is responsible for and paying attention to these things. So I now am saying, you know, if you are assessing some things in your process and your company that you think could be better, if your first idea is to look at a bullet list of problems and come up with a bullet list of rules, you're probably doing it wrong. But here's the positive side of what happens when anyone, whether it's all of us who have just sort of learned this the hard way, or if it's a developer who wants to learn this, this is what you get for dealing with it, right? You become able to quickly detect, identify, and diagnose problems so that you're catching them when they're smaller problems and they're easier to work on and they're not at the level where 500 people have showed up and said, oh my goodness, help, we're losing $10 million every hour and we have no idea how to fix it, right? So more people who have practiced those situations where they see something, something's not right, they look, they catch it, they react. You become able to prioritize things that are going on, right? Every company that starts to track what's going wrong is just gonna have a long list of things that will never be actioned. That's the nature of it, right? But how do you pick which of those things is actually important enough for you to respond to right now at 3 in the morning, or that someone else needs to respond to that? How you can study, as I mentioned, you can study all kinds of architectural principles in school. And obviously studying is important. We're all constantly we're just talking about learning, right? This is all just a system of getting better and actually learning from our real actions instead of waiting for someone to write us a textbook. So having an actual understanding of how some of these architecture paradigms work in real life is extremely eye-opening. And the only way you're going to really, really understand the exact trade-offs in your environment is by looking very closely at what is not going wrong in very small places. So it makes everyone's job easier if the problems are being found more quickly, because people are attuned to this, like, hey, I'm used to things being this way, and they're not this way. And now I think I might need to look at that. And that's a habit that we all have developed by being constantly in situations where somebody expects us to have known something was wrong. Like, this is just a skill and a habit that we build, right? And then I have my jokes here, which was people will think you have magic, right? I was gonna click time it, but you have a spooky feeling of doom all the time, right? You're like, oh man, I know it, it's coming. And service guarantees citizenship. You pick up that pager and you're part of us now, you're one of us. A lot of what I wanted to put in this slide deck is, again, like general concepts that are base level, because no solution is correct for every company, even if they're the same size. And I find it a little bit frustrating that, again, in the sort of like, we need rules, we need programs, there's a program that will fix this, right? Management loves this. What do you do when you want to change something? Well, you decide what you want to change, you decide how you think you're going to change it, and then you move this massive thing into place, and it starts changing all of these things. And a lot of humans don't really enjoy that part of it. But if you stick to the basic concepts, whether you're a one-person passion project posting this as open source, or maybe now you're growing from your one-person passion project to your 4 people that are helping you, and now maybe 50 people are helping you, and then you decide to start a company because you can sell this, and now maybe you have 100 people. All of these things are true the entire time. What you do with that information and that understanding obviously is going to change quite a bit, but someone somewhere is responsible for what code is doing in production. And again, this is falling on, obviously agreeing ears here, but if you're a developer and you don't know who is running the code in production, then some other poor person is now learning a lot of stuff about what your code does when users use it and it interacts with other systems, but you, the developer, are not knowing that. The next point there is humans need to make real-time decisions. Again, regardless of your size, when something isn't right, and it's especially something that you haven't been able to plan for, and those happen all the time, You want people, because people have this amazing ability. We're trying to spend all this money across the industry to do AI to just replicate like the reasoning of like a 5-year-old human, right? So humans belong in your system. When you look at an outage, don't, oh no, a person made a mistake. How can we cut the person out of this loop? That is not a good first step, right? So responding to these operational surprises, as I like to call them, it is a skill, and we've all practiced that skill, and we're all probably pretty good at it compared to some random person, right? And the skill is just that you're looking for problems and figuring out how to solve them, and then like finding them faster and solving them faster, right? One thing I will say is the less of this operational expectation that you're receiving from outside, the more you need to bring from yourself, and that can be extremely effective. Because think about, you all have teams in your companies who are doing very poorly, not non-operator type people, right? We have dev teams and their product is not doing well. And then there are some developer teams that they're running their stuff and their availability is great. And how does that work? And the answer is they have their own structure. They have somehow figured out how to learn these things quickly and take care of them. So the first thing that I'd like to promote as part of my grassroots effort here is DevOps Culture. This is a great time for an anecdote that is very recent and top of mind for me. Again, coming as like, I come from this ops background, right? I ops for life. And when we all get together, those of us who are basement dwellers, as some call us, right? When we get together, we share our pain about all of the times developers have done something wrong and the system has failed, and we talk about those things, and wow, you know what? First of all, very common, it's already happened to me once today. You'll tell some story, some other person who's done operations is going to go, wow, it's like you've lived my life. If anyone has read the book, The Phoenix Project, I read that, and I was like, it's like they made it like it's made up, but this is literally like, this is so true. This has happened so many times. It's uncanny. And the interesting thing about that is you come in a group like this, and I get up here and I'm like, let me tell you about the time a developer made a change that was not tracked in any way to a very important system, left their desk, and then 3 hours later, after the entire site has been down and CNN is talking about it, somebody finally figures out that this person changed something, finally figures out how to get a hold of this person. Once that thing is done, it's fixed in like 2 minutes. And when I tell that story in this room, everybody's just going, yep, yeah, that happened to me last Thursday. That's sure, yeah, that's a thing. Yep, that's normal. But when I go talk to people who are like dev only and they're not ops people, especially in my role when I was doing Postmortems, I would just go to a company mixer, again, working at a big company, you get to meet a lot of people. And I would say, hey, how's it going? Let me explain what I do. I analyze what went wrong in an incident and what we can learn from it and how we can do better. And then I would always get this story from them. They'd be like, oh, let me get this off my chest. You're the person I can tell about this. This one time, I accidentally pushed a change that caused a 50% error spike. And of course, I'm just like, oh, well, I've never even heard of that event. That doesn't rate on my scale of caring, right? That's too low level. I would never see such a thing, right? But every time, they're very like circumspect, and they're like, wow, I feel terrible that I had this effect. And I would always ask, well, did you tell your friends that you took something down or broke something? No. I find it interesting that the operations folks are happy to vent with each other and share this information, and we all learn things from those other situations, right? It's similar to our own thing, has that little extra detail in there that just changes your understanding of how to approach things. So DevOps culture is something that I want to promote amongst developers. Like, hey, when you make a mistake, you should tell everyone. I want to hear about your mistakes before your successes, and that's not how the business world normally works, right? So that's why this is grassroots. So here's how you do this in very broad strokes, right? Again, these are broad strokes. They're kind of basic concepts. There are very few places I would give you specific advice, regardless of what company you're coming from. So you as the developer, pretend you're all developers here. This is the line we're going to start giving to our developer coworkers, right? You should be the first to know that something is not going right with your software, because you are the person who is the expert. That's literally what we pay you for, is to make this and to know what it does and to know when it's doing something it's not supposed to be doing, right? And some of the ways that developers can do this, again, I'm giving examples so that we can bring them in, right? Like, well, what is deployment confidence, right? Depending on your organization size and the size of your project, that changes a lot. Maybe it's you have a giant dashboard, you have 20 dashboards, you just everything, like maybe you have a crazy cool CI system that when somebody deploys, it puts it into Canary, it does some other like limited testing, right? And it automatically looks at what's happening and says go, no go, right? Then that's kind of like a end stage, everybody wants that kind of thing, right? You don't need that. What you need to know is what happened when I pushed this? What changed? Did it change the way I expected it to? Meaningful alerting. This is something where I have recently had a really interesting set of conversations with developers. A lot of the time they say, oh, I don't want to be on call because everybody who's on call right now in real life, their pager's constantly going off and they're constantly annoyed, right? And we've all lived this. Oh, there's just noisy alert. It just pages me every time there are 5 errors. That's 7-1, and then I wake up and whatever, and I can't even do anything by the time I log in. So if you, as the software developer, are writing your own alerts that monitor your own software, A, you know what to monitor, hopefully, a little better than some random SRE person, right? Some random operations human. And if it pages you too many times, great, fix it. That's it. Like, nobody needs to suffer. If you just do it yourself, then you can just reduce the amount of paging, because otherwise you have to wait for somebody else to get so annoyed at your alert that they come to you and they're like, please get rid of it, right? Just skip that whole thing. Just tell yourself, figure it out. It's how you learn to make better alerts. It's how you learn what your software is doing. And then like logs, metrics, traces, again, it's tempting when you're writing a really small project, even if you're a member of a big company and just starting something that's greenfield, it's tempting to kind of skip all of that observability stuff, like real error messages that actually tell you where to look for the problem. Otherwise, you're sort of like, oh no, I got a generic error. Let me like search through the code base or search through Stack Overflow and see what this does, right? And then again, plan ahead for the parts that don't work. This is the first step, is your cycle that you set up because you know that's coming. The second part is also accept, by the way, sorry, that while you're doing that whole thing up top there, you're going to get some surprises. And what do you do when those surprises happen? And the things that are important and that make for successful, faster remediation of these incidents, faster restoration to the customer, you need communication. You need to support the people who are responding so that they can bring their full attention and that they want to show up to help with this incident, and not that they're being dragged and that they're being forced to sit there and watch. And then while you're doing all of this, think of ways to improve that. After you've responded to a few of them, come back, and just like in the top, everything is always a learning loop, right? That's a huge core SRE concept. And I have a little asterisk on here. It says you cannot prevent incidents, but you can make dealing with them better. There we go. So this is where, no matter what size your project is, again, pretend that you have never looked at this before. List out your tools, and your tools might be a pen and paper if it's just a one-person project, right? Like, yeah, I write stuff down, I keep notes, I decide what my feature list is later, and then when something doesn't work, I write down, friend in other team told me this thing is not working, and you stick your Post-it on your screen. Like, that may be all you need at that size, right? But know what the tools are. It's easy to know that there's an entire microservice environment at your company that's just dedicated to incident response, right? It's easy. Oh, yeah, that's the incident response thing. Of course, that's the tool, right? There's 50 million of them. But also, consider everything that you might use or touch or read or look at during responding to an incident. Look at that as a tool that you can evaluate whether it's like helping you or hindering you, or maybe it's 50-50 and you could just pivot it a little bit. Write your process down. This is a super, super interesting thing to do, because if you work for a larger organization, there's probably some kind of written incident response process. If you work for yourself, just one person, you still have an incident response process. You probably haven't written it down before, right? Go look at your written process if it exists, or don't look at it and write down what you think the process is based on your experience of doing it. Compare it to what's written down. If it's not written down, maybe you can write that down. But is it working? Before you stay with that, is that working? Which part is not working? Which part is working great? You need to know which parts are working well so that you can evaluate those also. Because something that works for you really well right now won't work for you forever. And it's impossible to know in advance where that line is. But you can just be aware of it, and it's one of the things that you're trying to learn as you go through these steps. So again, I think it's really helpful to actually write down what you think these tools and processes are, and kind of maybe if you have multiple people on your team, see where people don't know about something, see where the gaps are. And again, maybe you sit down with the developers that you're working with if you're an embedded SRE, and you ask them to join you in this, and you say, let's write down what we think we're all doing here. Let's see if that's true. And I want to invite people into these discussions and teach them how to be part of our discussions so we can all evaluate and fix things, right? Improve things, I should say. Fix is a misleading word. So, like I said, your approach is going to change over time. These are some kind of like super simple examples of what you might get when you write this down. This is my one-person passion project. Maybe somebody hits me up in Slack and says, I tried out that thing you pasted me a link to. It didn't work. Whether or not you need to like open a ticket for that, probably nobody is forcing you to do any of this, right? So maybe your real process is you file that away in your mind or your little post-it note or something. But it doesn't require or involve anything particularly costly or even, annoying. Like there's not a lot of steps here. It's all very simple, but just to understand that that's where you're at right now is very valuable, because when you keep sort of looking at this and understanding what you're writing down here versus your incidents is how you eventually end up at this point where I can't click. There we go. This is your global scale. This is, no offense to Google, this is like the way that Google does it, because they have been on this journey from this very first person, one-person project, and they're at the end stage of that journey. And they're a really big company with a lot of money. And there's a huge difference between any of these lines, right? We're talking about pen and paper versus, again, a cloud, an entire cloud just for incident, right? Don't think that that is everyone's end state, right? You don't need all this big company stuff, possibly ever, depending on some of your approaches to things. So one thing that I like to use as an example of introducing people to incident management in general, I love the FEMA incident command system because, and here are the reasons, okay? It is cross-disciplinary. It is based on actual, like, real emergency response. I was trained in FEMA incident command when I was an EMT. I trained for mass casualty incidents. I trained for these things to happen because we know they're going to happen. We're not going to prevent awful tragedies from occurring, but what are we doing when we get there? And it gives people that perspective to think like, wow, if this is what works when literally, possibly like thousands or millions of lives are on the line, it's an interesting concept. It works pretty well. I worked one mass casualty incident, which I am happy to tell you didn't really involve many casualties. If anyone remembers when Sully Sullenberger landed that jet on the Hudson River, I showed up. I was a volunteer EMT. I showed up, and I was not even wearing a uniform. But because I am so skilled at operations and because I am so calm during those crazy events, people saw me in my civilian clothes looking very calm and purposed, and they assumed I must be really important. And I was like talking to the head of the state police and the FBI and all this stuff and helping them out and doing things. This is a great system to understand the concept. I do not think you should just replicate ICS. I don't think anyone should just do ICS for computer stuff, because this was designed to help fighting wildfires and plane crashes and terrorist attacks, right? These are some of the key concepts that the incident command system, I think, encapsulates very well. So again, this slide deck will be available. I'm not going to go through every one, but I like the completeness of the incident command system because it addresses a lot of these things that are very, very crucial and or just helpful in responding to incidents. Here's the breakdown, right? If this is, once you've read the ICS, seen a real system at work, right? It's a great example of an actual usable incident command system. What it's providing for you is, number one, a facilitator. This is what a lot of people refer to as the incident commander or the incident lead or NOC technician or whoever's in charge of what's going on here. And this role is super important because the facilitator or multiple facilitators of your incident actually can kind of like make or break your response. And I think this is an area where, again, there's not a lot of specific training that's generic that explains the concept of facilitating an incident response, right? I've read so many special, like internal company guides of like how they do it at this one company, but obviously they're all very different and they don't apply to anyone else's use case. So you need a facilitator, you need an appropriate engineering response, okay? And what I mean by this is the facilitator exists there to keep track of what's happening, what is needed, where things are at, and the appropriate engineering response is whatever subject matter experts might be required, they need to be gettable by the incident commander, okay? We need to be able to find the people who can solve our problems. It turns out it's really tough to facilitate and fix at the same time, so that's viable in like one-person situations only. Once you get larger than that, if you can possibly bring more people into your incident, it's important to do so. Again, with the communications, you need to communicate to upper management because they want to know why they're losing money right now. You need to communicate possibly to the public. Part of my role as an incident commander right now is literally to tweet on behalf of my entire company to say, I'm really sorry to tell you that it's broken right now. And then we need to foster the communications between the people that are that appropriate engineering response. We need, for example, a Slack room where they all come together to be facilitated by the facilitator and the processes and the tools that are there as we get bigger. But there needs to be an understanding, right? This is agreement on the plan. The people who you're going to page need to understand, hey, I'm going to page you. Here's what it means. Here's what we need from you when you get paged. I'm only going to page you if it's really important, if I can help it. And then I expect the following things to make it go better. Accurate timeline and data. I know that we heard this in the postmortem talk. Let me tell you how many actual fights I've seen in an office because we started a postmortem meeting without a detailed timeline, and some teams thought that their data was not, their activities and such were not accurately represented. Having the ability to easily collect that information while you're going is extremely helpful, extremely helpful. I actually even already discussed today, like, a lot of times places will just record the phone conversations or the Zoom chats or the Slacks, and then some poor human being has to go through that entire thing and like write a transcript or go pick out the things that are meaningful. That's a waste of time. I have personally never done that, having done a million of these high-stakes postmortem meetings. I've never reviewed an 8-hour transcript. Nobody wants to relive an 8-hour crappy incident, right? So make it so that while you're doing it, again, if you're practicing this and you're iterating, you already know what you're going to talk about later in those meetings. You've been to a meeting or two, right? You already know the kinds of things to call out, like, yeah, we've talked about this sort of thing. Didn't go so well last time. Seems like that's happening again. Like, this is all operational mindset, right? Which things stick out to you in your mind as a result of experience. And all of our developer coworkers are just as capable of learning these things. And then review and improve, obviously, right? So you need that data to be able to review. And when you're reviewing here, you're not looking for, did we stop all the incidents from happening, right? That's not what we're looking for. What we're looking for is anything from this incident, is it like the last one? Do we have other things that keep coming up? Are we noticing trends that maybe if we address that, it will improve things overall, but not we can fix it for next time, right? How do we just make people feel better is a big thing. So yeah, postmortems, super hot right now. Everybody likes to talk about them. Since we've already heard a little bit about it, most of what I wanted to say is be careful with your postmortem process because there's a business need to find out what happened and what we're going to do. That's just a regular business need. But when you get into these meetings, if people are not participating in these fact-finding types of meetings on purpose, if you start with some management person saying, I don't see anyone representing this team, and this team, you go get them in here right now. I can tell you that meeting is a waste of time. Just don't even have it because all you're doing is making a bunch of your employees really mad, assigning them a bunch of work they don't want to do. They will let those corrective action tickets fester in their queue or their backlog or their icebox or whatever it is they're using forever. And even if you get their VP to tell them to fix it, they still don't want to fix it because in their mind, they were called into a meeting, yelled at, and then told how to do their job a different way, right? So the postmortem is not a place for accountability. You need accountability in your business, and it doesn't belong in the postmortem because if people feel like they are defending themselves and their product, they're not willing to raise their hand and say, actually, my product wasn't even really involved in this particular incident, but I think if we significantly changed how we're doing things, we would help a couple of these other teams. And then you get some other teams jumping in and going, oh yeah, and we could do this other thing too. And that only happens when they feel like they're here to solve a problem and not here to account for their actions or to defend themselves or to defend their product and their honor. So I know it can be difficult to sell management on caring about the humans, and it sounds very wishy-washy, and it doesn't sound like a thing that has a place in business. But having experienced the difference between a meeting where people are pointing fingers at each other for real and screaming, and having those same people come back, even though upper management wouldn't let me stop blaming them, I just stopped blaming them anyway. I did some guerrilla warfare stuff here. I just made things happen. Those same human beings who seemed like they weren't capable of having a civil conversation were suddenly volunteering to work with each other and giving themselves work. And guess what? When you volunteer to do a thing because you think it's helpful, you're pretty motivated to do it probably, right? You don't need some person to come nag you and say, you have 50 of these, why haven't you done them? Because you're interested in improving things and you want to learn about it and you want to help. So another big thing in SRE and operations and development, talk a lot about the wall, right? It's change versus stability. This is the tension that we have, right? And the reason that the friction comes up between dev and ops is because ops wants no change, because no change is stability. Guess what? If you don't touch things, they break less. Great, that's what we want. Change is how you get the new cool features. Developers want that, management wants that, everybody wants that, except whatever human being has to deal with the fallout of that and has no meaningful input into making any changes, right? So it's definitely a very tricky conversation to have. And depending on your organizational size, it may be appropriate that you have entire teams of people who are dedicated to making tools and processes that track what changes are happening, make it possible for you to know what changed. But in a lot of cases, that is not a well-developed area of the company. And also, this is something that's been changing business-wise, right? It used to be that I got to submit my change to the change board. The change board looks at all the changes that we're trying to schedule for the week. They decide all those things can happen at once, and then they say, okay, but you have to submit that change 2 weeks beforehand, and so you can't get anything done now. All you want to do is just toggle some setting to see what happens when you do that. Like, it's a super simple thing, but because all changes now are flagged as a risk, everything is gated, everything is slow, and business doesn't like that. And now continuous deployment, like your management will come to you and say, hey, you can't stop my developers from shipping, they quit. Do you know how much it costs me to get those developers? How dare you? No, I want them to ship constantly. So here's what's interesting about continual deployment, right? We went from a model in business where we were pretty sure we knew what was going to change, and if we didn't know what was going to change, that's your fault, person who changed it. We see you, we're coming for you. We're going to make it so you can't do changes without letting us know first. But that doesn't scale to the current level of what we're doing, right? So how can we allow rapid change and mitigate some of that risk? Well, part of the problem is all of this change, there's so much change, and there's so many more moving parts, and all of them are changing more, and people want even faster change. We have entire teams that we pay to make it faster, to change things now. You need to understand your service. You may not be able to even fully understand the complexities of your own service the way that many software packages like work these days. Like, just while you're making it, it gets really complex, and as it grows over time, more people have been doing different things. You don't know how this section of it works. You start to pair it with new services that come online in your environment. They've never talked to each other before. Now you have a bunch of services that nobody's quite sure how they really interact with each other in real life. And you have users using them too most of the time. So this is a recipe for absolute confusion, right? So what you need is everybody that writes code needs to understand their own code, and they need to be responsible for their own code, because it is absolutely not possible to staff an ops department that receives the software and just runs it in production. Like, it cannot work that way anymore. So cross-team chats and meetings are super helpful for this. If there are some teams where you become aware that, your software doesn't particularly interact well with theirs sometimes, and it's an important flow and customers care about it, and it's just, you keep having these problems, you start a Slack channel together with them. And when you see something a little weird that isn't worth opening a ticket about, ask there, right? And encourage that kind of behavior that, hey, you need to know what's going on. You need to know what your product is doing. You need to support other people in using it. And also, let me just say, it won't kill you to write a document, okay? Everybody's like, oh, nobody's ever going to fill in the document. You can get people to fill in a pretty bare minimum amount of documentation, and you do need a bare minimum amount of documentation, even for yourself. So please encourage people, thank them when they do it, help them update it when you find something is wrong in a very helpful way. Like, hey, I noticed I heard this thing, and it doesn't match what's in here, and would you like me to update your document for you, right? So these are the sorts of things that, again, if you're a small team and you maybe don't have the benefit of a massive set of magical tools that just show you what you changed recently or what other people changed, if you have no way of knowing this, you need to be able to figure out via whatever method you have now, what just changed? Like, hey, I see this graph was like this and now it's like that, and that's not what I want. But what was happening before, right before this? What do we do? How do we find that? Probably somewhere, regardless of the size of your project, there's probably a bunch of different logs and trails of things, and you can get a pretty good representation of a lot of things that changed. And then you have this problem of okay, fine, I just found 10,000 things that changed in the last 5 minutes. Which of those 10,000 things do I care about, right? So you need to be able to quickly discern. You need to develop a system that lets you know, what are the blast radiuses of each of these types of changes, right? Am I looking for the ones where storage is involved? Am I looking for the ones where some other thing is involved? And if this is a YAML update for a non-production, non-critical system, I probably would not start there as my first place to look for what's going on, right? So then you need to know who changed it. Was it a person? Was it a script? If it's a script, you need to turn that off. If it's a person, you might want to ask them what their change was supposed to be doing. Can we roll it back? I mean, literally, that's a question. It's just a question that you might find yourself asking in an incident. Hey, is it possible to roll this back? Because it might not be. In some cases, you have to do some migration, and there is no return, and there's only fixed forward. It's helpful to know that before you start that. Have we done this before? Did it go well? Does it traditionally not go well? Do we need to spend a little more time paying attention to this one? And which of our types of changes have the most failure? And I want to be really clear here. I am not in any way suggesting that we just take a bunch of lists of what went down and come and say, you team, you fail the most. You're in trouble, okay? What I want is for us to all take a look at the types of changes and when we change things, when we change how these two things talk to each other, that has gone really poorly every time in the past. So maybe it's time to start to look at that, and maybe you see that, and you see that in a few areas of the business if you're all talking to each other. And then you start to realize maybe we need a culture shift, maybe we need a new tool, maybe we want a new process, right? Imagine if developers were asking you for a new process for how to ship things. Can you even imagine that? Totally a thing that's possible. It has happened to me. And one thing I wanted to point out specifically is code freezes. Coming from a deep ops background, code freezes are the best. You're like, yeah, code's frozen. I can go on vacation. I can actually sleep. This could be so good. I don't know if anybody else here has had this experience. I know that you've had this experience. There's a code freeze, and there's a code freeze because, let's say, you are some sort of business that has a very peak season or even a very peak day, and you have these events that are so crucial to your bottom line. Black Friday is a great example. It's named Black Friday because it puts companies in the black. That's a big deal, right? Totally normal that management is going to say, okay, this is the one time we'll let you stop people from changing things because we absolutely cannot have our stuff go down on Black Friday. This is our one day of the year we make all the money. This is how you get your bonuses. This is how I get my stock, whatever, right? And then what happens in real life is, there's a code freeze. Hey, I need to make this change. Well, you need VP approval. You need senior exec approval. Guess what? They never say no. They never say no. And in fact, I've experienced where not only did they never say no to the exceptions, they came back and they said, the developers are kind of annoyed that you keep making them get exceptions and that you won't let them work for this week, and they don't like it. And the executive that paid all this money and developed this developer thing, all the best developers, that's what people are focused on, right? They don't like it when their employees complain because they quit. Do you know how much that developer cost, right? So we can't do code freezes anymore. They don't work because nobody wants to participate in them other than the people who are like, excuse me, it is my problem when this doesn't work. Those are the only people who are actually motivated to stop the change. So if you feel that the only thing that you have left in your organization to protect yourself on a crucial day is to just freeze all of your changes, that's a great sign that you need to really, really look at how this is working and how you can better, again, like how you can improve your incident response, how you can improve your problem detection, how you can improve the people who need to do all of those things. Computers are not going to detect all of your problems for you. They're certainly not likely to detect the ones where it turns out you were down for 10 hours, right? Those are the weird anomaly events that you could not have predicted, and those are the ones that you care about the most. So chaos engineering is my one quick fix solution. You want to get good at ops? Good. Do it hard. Okay? I know what happens when I unplug that database. You know how I know what happens when I unplug that database? It's really simple. Let me tell you what happens when you go pull the power plug on that database. Stuff can't access the database, right? Duh, we got that. I'll tell you what else happens, and I'm positive about this. Not only can things not access the database, a whole bunch of other things that don't talk to that database also don't work anymore. And people are really confused by that. 100% of the time, this is what happens when you pull the plug on that thing. You're like, okay, I know that this won't work, but what is this? Why are they even touching this? They're not supposed to be touching this. What is this? So chaos engineering, you're scheduling your outages in advance. You're scheduling them. You're saying, listen, we don't know what happens when the database goes down, this particular database. We need to know what happens when this database goes down. Let's pick a time. We'll all get together. We'll talk about what we think is going to happen when we unplug the database. We'll talk about, based on knowing we're going to unplug it, what can we do to sort of mitigate this? What can we do in advance? What planning works, right? And then you go pull the plug. Guess what? Then you write down all the stuff that was a surprise. How exciting. Wow, we didn't know any of that was going to happen. But doing that over and over again is a great way to just do what we've all done the hard way, except in a supported environment where you know that 4 p.m. on Tuesday is when your database is going to be down. You know when your outage is, right? So you're thinking, okay, great, I'm canceling my dinner plans. I make sure I have a babysitter or whatever. I'm going to come to work late. I'm going to sleep in. Whatever that is that you want to do to kind of come well rested, right? What do you have an opportunity to be like, yeah, I know when the incident is. We're going to do it, right? So it doesn't have to be fancy. You don't need tools. You can buy lots of tools. You don't need tools. You just need to know. You form a hypothesis about how the software works together. Figure out how to test that hypothesis. Every single time you're going to be wrong. And then you just learn from that. You do it over and over again. And if you do it on purpose, that's better than doing it the hard way. I definitely can tell you you're still going to do it the hard way. But you're not going to have to do it as often the hard way if you've done it the slightly easier way, right? And I like to summarize this up with, the Mark Twain quote, if it's your job to eat a frog, it's best to do it first thing in the morning. So at the beginning of your project, when it has two components, you have like your Ruby on Rails thing that you stood up and a MySQL instance, and that's it. And it does very simple things. And okay, great, it does very simple things. Turn off the database. What actually happens, right? What can you do to make it so your users can still do some of the stuff while that database is off? Now's a great time to figure that out, right? So if all of the developers are embracing chaos engineering for themselves and making the time to practice these things, they're going to learn what we have learned by doing this the hard way, right? The unplanned, the surprise. You just wait for the surprises and then you learn, or you can make the surprises happen on a schedule and you learn even more. So one area that I think is very tricky to discuss, especially with smaller teams, but actually even with large ones, is the concept of operational maturity. And I think this is an area where developers often they've heard of it, especially at a larger company, but they don't really know what it means. Like they might think like, oh, like you've operated for a long time and you're mature in it. No, operational maturity is a way for you to figure out what you are okay to depend on based on your needs, right? So if I'm a passion project developer, I need, some EC2 instances. I need RDS or something, whatever. And I'm going to think, well, all right, I can get this from Amazon. Their uptime is, I don't know Amazon's uptime off the top of my head, but it's whatever. You can find this out, right? Well, you know what? That's even more than I need. Is there a cheaper provider for this? Because I don't need it to be up all this time, right? So understanding what your needs are and being able to evaluate your choices based on those needs is really crucial. And that's difficult to do in a complicated environment because at big companies, you get all these platforms to make it easy to make tools because, we love when somebody just makes a new thing that does something we wanted. And if we make a new thing that does something we wanted, it's great. Let's say I'm going to develop an application to guess the color of my coworker's socks, right? The operational maturity I require for that is like 0. I don't care if it goes down. It just does not matter to anyone, literally, right? But I stand up this service, and I used all the automated tools, and therefore other people that work in my company can find this service, and they see it, and they go, I think I could use this in my project. So they build it into their project. And they've had this project in alpha, secret mode, whatever. They're not even out of beta, and they've already been working on this thing and testing it and poking at it for like 8 months, 10 months. And they're like, yep, we got this. We've done everything. This is so awesome. We're ready to go. Put it in production. Great. A month later, the database it relies on goes down, and it doesn't come back. And they're like, what's going on? Oh, where's the database? Turns out, the people running that database, well, that was their alpha project. And it never went down while these other people were using it, but there it is. So you need to be able to understand where you are in the cycle and to understand where other products are, whether that's outside or inside of your company. And you need to be able to express that in some language that everyone at your company can use to compare these things. Don't make them checklists where you have to get a score where it's just like, oh, I'm minimum compliance. You need this thing, the file to exist, great, it exists, bye, have a nice day, right? This should be a conversation for everyone that says, okay, do I know who owns this? Is someone backing this with a budget, right? Is that important to me in this case? Maybe it is. Maybe I need to know the lifespan of this kind of thing, right? Maybe the defined escalation path, again, if nobody needs your service, maybe you don't need that. So these are scores, and maybe you don't need 100% on all of these, but I want to see where you don't have the high scores, just so I know. Maybe I shouldn't depend on your service, even though it's there. I think it's actually really awesome to start out by letting users self-score so that they start to really understand the system and they ask the questions. And the one last thing I wanted to touch on was SLOs. This is one of these terms that gets overloaded. An SLI is a service level indicator. Can I ping it? Can I log into it? Is it up? How many HTTP 200 responses did I serve? SLOs are how much do I want my customers to do that? My customers want HTTP 200 responses, right? How many of them can be not 200 responses before they get mad and stop paying me? That's what your SLO is. SLA is something that is hopefully much more generous with downtime than your SLO because that is where the paying money comes from, and that is the thing that the upper management cares about. So SLOs are awesome for developers because if you are thinking about what your customers care about and you're instrumenting to monitor what your customers care about, you know when you're making changes, you're not doing wrong things for your customer. That's it. That's the whole reason. It's super important that you understand that as a developer. And when I've explained this to developers, they're like, oh, yeah, you're right. I care. So again, how to make an SLO, understand what your users want. It might take you some time to do the math on getting it right, and that's understandable. This is hard, okay? This is involves calculus and stuff, right? I don't expect every developer to become an expert. I want them to understand it is an area of expertise, and I want them to seek that expertise, right? And to know that it's something they need to think about. So in summary, everything is complex, everything is crazy, everything is chaos, right? This is a whole new world. We haven't quite learned to adapt to it yet, but if all of us are sitting around thinking of, okay, how can I know what my portion of this is doing? How can I make it better? And most importantly, how can I learn as I go and not miss out on that learning by dumping it on a different human being who maybe isn't as attuned to learning? All they learn is that it went down and they don't like it. Not that you should change some paradigm or use a slightly different search product or something, right? And then another fun anecdote. This is my resilience engineering slide. So this is the academic study that is starting to happen. And since you're all kind of next level ops already, resiliency engineering, Please go Google this. Please click on these links. If you just Google it, you're going to find stuff. Go look up John Allspaw from Etsy. You find his name, you're going to get down that rabbit hole. And you'll start to understand that there is actually academic research that backs up caring for the humans. It's crazy, but it's here, and this is how we move the needle. And my last little meme here is, do it. Yeah, okay. So I'm going to summarize this little tweet stream here. Basically, the original tweet was, please reply to this with the following. 1, ops or dev. 2, what comes to mind when I say JVM? Now, the people in this room, I'm pretty sure, are going to have similar responses to the 300 or so that he had before this came out. Mine was also probably what most of you would think, which is ops and JVM. Okay, garbage collection, I hate it. I can't tell what's going on in it. It's the bane of my existence. Everything about it is not as fast as people claim it is. Like these are the kinds of things people were responding. And look at this response right here. I forgot that ops, capital O, ops people, right, often felt this. A developer says, oh, here's my jar file. Good luck, chumps. Bye. Right? So most of the developers don't realize that that's what's on the other side. And if we not just complain to them like we have before, like, you guys don't understand, you dump it on us. If we say, I've been learning all this stuff about your product. Wouldn't you like to learn this? They care. And so we all can do this together. We can bring them into the fold. We can still have our little vent sessions, but we can also be positive and say, look, if you start learning this stuff, it's going to be awesome. Thank you.